Since the definition of continuity is central to this course, it might be a good idea to learn how to negate the definition properly, if not for anything, to use in proofs. Let's write down the definition of continuity in logical notation. So again, the setup is, let f from a to r be a function and x is an element of a. Okay, now we say f is continuous at x if for each epsilon greater than 0 there exists delta greater than 0 such that if x is in a and mod x minus a, not x is in a, if y is in a and mod y minus x less than delta implies mod fy minus fx less than epsilon. Okay, so this is the logical notation for the definition of continuity, at least the epsilon delta version. Now, how would you negate this? Well, it's pretty simple. This for all epsilon becomes there exists epsilon greater than 0 and the negation sign moves inside. This there exists delta greater than 0 becomes for all delta greater than 0. Okay, for all delta greater than 0 such that y in a and mod y minus x less than delta implies mod f of y minus f of x less than epsilon means for there exists epsilon greater than 0, for all delta greater than 0 there exists y in a. So to understand why there exists comes, let me change this such that and make it for all y. For all y in a such that mod y minus x less than delta implies mod f of y minus f of x less than epsilon. You will understand why I have phrased it this way. It will become very clear because only then do you see that there exists y in a such that mod y minus x is less than delta. So how do you negate an implication? Well, the antecedent should be true, but the consequent should be false, such that mod y minus x less than delta and mod f of y minus f of x is greater than or equal to epsilon. Okay, so what is this definition saying? There is some epsilon greater than 0 such that no matter what delta you choose, there will be some element y in a that satisfies y minus x less than delta, but nevertheless mod f of y minus f of x is greater than or equal to epsilon. So this choice of epsilon plays spoil sport. What this is saying is, no matter what delta you choose, that in other words, no matter how close you get to the point x, there is always some other y that is closer to x such that mod f of y minus f of x cannot be brought epsilon close. So this is the formal way of negating the definition of continuity. Okay, so I'm going to leave it as exercises for you to write down in logical notation the other two definitions of continuity, and negate them. Okay, this is a course on real analysis and you've just watched a module on negating the definition of continuity.